Welcome to Spring LIB.
So we're going to start off with a formula where we can pick a value for width and get a value for the lengths of the other sides. So it's going to be 750 minus 2w. And since we have 750 feet of fencing to work with, we subtract 2w from it to get what's left for the other sides. And then since there are 5 parallel sides, what we have is that P is equal to 750 minus 2w over 5. So we could alternatively make a formula where we pick the length of the 5 parallel sides instead. But this is what our fencing is going to look like. So we have 200 feet here, 70 feet here, and then it'll be broken up like this. That would give us 70 times 200, which equals 14,000 feet squared. There's other drawings we could do that would give us 9,000, but experimenting with numbers, the max area we seem to get is somewhere around here, but we want to figure this out for ourselves. We want the absolute maximum. So for 11b, so part B, we're going to let one side of the overall pen be x and the other side be y. So it's going to look like this. So this is going to be, we can call y, this will be x, and then there'll be the rest of the pen and all of its subdivisions. Then we let it be the x width and the y length and a area. So a is going to equal x times y. So then for part, that was C, so for part D, what we have is letting x be the length of the end wall and y be the length of the dividing wall. What we end up having is 2x plus 3x. So this is the 2x, and then there's the 3x right here, 1, 2, 3. And then we have 2y right here and right here. So plus 2y is going to equal 5x plus 2y. And we know that 5x plus 2y is going to add up to equal 750 because that is our amount of fencing that we have. So now we can solve for y, and we get y equals 750 minus 5x over 2. And we know that a equals x times y, so we can substitute that in. So we get a equals x times this portion, so we can just rewrite that as 375x minus 5 halves x squared. Then on top of that, for f, what we can do is differentiate this area, and we end up getting a prime being equal to 375 minus 5x. We set this equal to 0 and see that x equals 75. So what that tells us is that since when a prime of x is less than 0, you get when x is greater than 75, and a prime of x is greater than 0 when x is less than 75, what we see is that x equals 75 is a local max. In that area, a of 75 is going to equal 14,062.5 feet squared.